Hello, everyone. Mr. Minix, my name. Math is my game. I'm really excited. This is the inaugural lesson of the 2017-2018 school year that I'm recording. I'll be putting this up on YouTube. So shout out to anybody watching this back on YouTube. So the title is the title's relevant. The section number 1617. It depends on what book you're using. I'm using two different books. So the homework might actually say 17 if you see a section on the homework. But anyway, it's the title, the subject is absolute value equations and inequalities. You thought I forgot about the inequalities. Those are the scary ones. Those are the ones where you get to row a rowboat and you get to lift weights, a barbell. You'll see what that's about by the time it's all said and done. So the objective, the goal, you should be able to write equations involving absolute value. You should be able to solve equations involving absolute value. On the pre-assessment that all my Algebra 2 and 2A students took this year, there was a question about tolerance. Anybody remember that one? Something about 100 yards plus or minus 4 inches. We'll address how to answer something like that today as well. The content standards, you don't need to write those down. That's just if somebody from the state or if the building principal were to walk in and say, hey, are you doing what you're supposed to be doing? Well, yeah, I am, because we're addressing those two of 44 content standards. So let's just get right to it. Love starting off with definitions. I'm a definition nut. Absolute value of a number or quantity. Most books will define the absolute value of a number, but they won't go on to define the absolute value of a quantity. There's a reason I mentioned quantity. Quantity could be something like x, could be something like x minus 6, could be something like 17x plus 32. So let's just slow down and slow our roll for a minute. I like these little thought bubbles. Thought bubble. In 6th grade, my teacher said the absolute value of -3 is equal to what? Anybody remember? It's 3, sure. And the absolute value of 11 is 11. And you thought to yourself, absolute value is easy because the answer is always positive. Remember thinking that to yourself? Okay. Anybody know why the answer is always positive? Yeah. Oh, it's the value of the number to 0, or how far the number is from 0 on the number line, right? And that's very crucial, and that's why we're defining the absolute value. Awesome. Shout out. Do you mind if I shout you out on YouTube? Shout out to Mr. Joey Fresh. He knows what's up. It's the distance. The distance. Or maybe I should say its distance. The absolute value of a number is its distance from zero on the one and only number line. The number line is one of those things that oftentimes we take for granted. We're like, yeah, we know what it is. Well, do you really? Do you really know what the number line is? Do I have a number line in here? I don't. Yeah, I do. There you go. There's a number line. Okay. So the number line should extend on and on forever and ever and ever and ever. And if you picture 0 somewhere here, and we're talking about something like the absolute value of -3, what we're asking ourselves is, how far is -3? How far is -3? How far is this number? What's the distance from here to here? What's that distance? That's what we're really asking when we ask, what is the absolute value of -3? How far away from 0 is -3 on the number line? Okay, how far away is it? And if you think about distances, if I told you how far I drive from home to here, I wouldn't tell you it's -12 miles. I would tell you it's 12 miles. If someone asks you, how long is your left thumb? You wouldn't say negative 2.6 inches, you would say 2.6 inches. You with me? Good. All right. So I think we just answered that question. An absolute value equation has a variable with the absolute value sign. For example, the absolute value of x equals 5. And the book is saying here the value of x can be 5 or negative 5, since the absolute value of 5 and the absolute value of negative 5 both equal 5. So they're kind of introducing how you go about solving one of these things. And so when you solve a real simple one, like the absolute value of x equals 5, the answer is that x is equal to 5 and or x equals negative 5. I think most people get that. But there's a false assumption that we oftentimes make. Anybody ever make an assumption about something? I told you the story about my wife and the purse in the El Carlos restaurant already. That was kind of embarrassing. The assumption that a lot of people want to make is that whenever you solve an absolute value equation, the answers are always plus or minus the same thing. Get that assumption out of your head. The answer isn't always going to be plus or minus the same thing. Okay? I'll go on record and write that down. The answers, the solutions aren't always plus or minus the same number. That will happen a lot, but not all the time. Anytime you have something like the absolute value of x with nothing else inside the absolute value bars plus some number a equal to some number b for any real number a or b, as long as the difference between a and b, actually b minus a, as long as that is a positive value, the solutions will always be plus or minus the same thing. But what ends up happening is a lot of times we'll have something like this: x plus a plus b equals c. If we have something like that, one like this all of a sudden is where the answers aren't plus or minus the same thing. So I've put a couple general cases. We're going to work a lot with general cases this year. I don't do this to confuse you. Really don't do this to confuse anybody. Let's see. I used to have a nice box here that, there we go, a little highlighter box. So that general expression, that will have the answers of plus or minus the same thing. But the second we have something inside the absolute value being added or subtracted, now our answers won't be plus or minus the same thing. So let's take a look at example 1. Let's see if we can figure this one out. Problem 1, I don't like the way they ask that question. They say, what is the solution? I don't like the way they ask that. Who can read my mind and tell me why I don't like the way they ask that? What do you think? The solutions. There's probably going to be 2. And in a second, we'll explore why there are 2. Okay, so when I think of something like this, I'm thinking, here's 0 on the number line. And this is why you set these up the way you set these up. This statement right here, that equation is really saying that the value 2x minus 1, the quantity 2x minus 1, is 5 units away from 0 on the number line. The quantity 2x minus 1 is 1, 2, 3, 4, 5 units away from 0 on the number line. Those of you that know the number line know that the number line goes from 0 out to positive infinity, and it also goes the other way, doesn't it? From 0 out to negative infinity. So the deal is this 2x minus 1 quantity could be over here as well. So I would strongly suggest anytime you have an absolute value equation of this form, that when you set it up, you set up 2 equations. That you set up 2 equations. One is 2x minus 1 is 5, and the other is 2x minus 1 equals negative 5. Okay? So the one equation you're going to set up is identical to the absolute value equation with one exception. You drop the bars. The other equation you set up is identical to the first one, but you change the sign, the SIGN, the sign of the number on the other side. You picking up what I'm putting down? Is this all making sense? You remember doing this in Algebra 1? All right. So if we were to just have solved the one equation, let's see what we get for the answer. What should I do to get x by itself? Add 1. So we get 2x is 6. And meow, what do I do? And I did say meow. Divide by 2. So our one solution is that x is equal to 3. Now the shortcut way of going about answering this question is to say, well, x equals plus or minus 3. And I went on record and said the answer is not always plus or minus the same thing. So let's go solve the other equation and see what happens. Solve the other equation. So we're going to add 1. So we get 2x is negative 4. And meow, we divide by 2. And what do we get here for x? X is negative 2. Whoa. Whoa. So x doesn't equal plus or minus the same thing. Interesting. Now, they wanted us to graph the solution. So we solved it. They want us to go ahead and graph the solution. So, I don't know. When you graph the solution, they want a number line. Here's the number 2. Here's the number 3. Anybody know what we should do with the number line? What we need to do here? Just going to put some dots on it. Are they going to be open dots or closed dots? Closed dots, because x does equal that, and x does equal that. Okay. Now last week I mentioned that there's more than one way to the Eastwood Mall. There's more than one way to solve an equation. The equation that we're solving is that the absolute value of 2x minus 1 is equal to 5. We mentioned last week that you could solve that by graphing, so I just want to reaffirm that. It's okay if you don't have a TI Inspire before you, but I'm going to go ahead and use my Inspire and just show you that if I graph, got to make sure I find my absolute value bars. Whoop, don't need two equal signs. There we go. Absolute value, I said absolute value of 2x minus 1, and I'm going to add a second function, 5 here. I'm going to try to add a second function. There we go. So my answers are the x-coordinates where those two graphs intersect. The answers are the x-coordinates where those graphs intersect. So if I use my analyze and I calculate the intersection, there's one there. If I use my analyze and I calculate the intersection, there's another one over there. So my answers are the x-coordinates where those graphs meet. So negative 2. Positive 3 are my answers. What do you think? Got it? Piece of cake? Everybody going to be a boss at solving absolute value equations? Today feels like a Monday for some reason. I don't know why, but to me it just feels like a Monday. I'm really, really tired. Really could use a couple hours more sleep. But anyway, on Mondays I always come out talking about weird stuff that's going to gross you out. I don't mean to gross you out. I don't want to diss anybody's world cultures, but we're going to be talking about something that's kind of gross in a minute. So, all right. Problem 2. It's a lot like problem 1. This one kind of reminds me of spending the night at a hotel. I know I've mentioned this at least once so far this year. Anybody ever spend 2 nights in a row at a hotel? You know what happens, right? The next morning about 10 o'clock, you're in your room. What do they say? Housekeeping! So the deal is, what I mean by that housekeeping is that when you solve equations, you want to get the variable by itself. When you solve absolute value equations, you want to get the absolute value expression by itself first. Make sense? So just like before, we're going to do PEMDAS backwards, or SADMIP. So I'm going to go ahead and add the 1. So I'll get 3 times the absolute value of x plus 2 is equal to 9. Now, some people love, and when I say love, I know that's a strong word. But when I say love, I mean they want to make out with it. I mean they want to take it to the prom. They want to put a ring on it. Some people love the distributive property, and they want to distribute every time that they see a number in front of some parentheses. In this case, we have absolute value bars. I got news for you. Distributing would actually be counterproductive here. Okay, so that's 3 being multiplied by that quantity. Guess what we're going to do with the 3? We're going to divide. We're going to divide. Okay, don't use a distributive property here. We're going to go ahead and divide. So we divide by 3. We divide by 3. So we're left on the left with the absolute value of x plus 2. And what's 9/3? All right, 3. We're doing good. They want us to graph this one too. I don't know why they want us to graph these equations, but whatever. So remember, we're setting up 2 equations. X plus 2 is 3. X plus 2 is -3. Awesome. So our solutions are going to be that x equals what? X equals -3 minus 2 would be what? -5. And the other one, x would equal 1. So our answers aren't plus or minus the same thing. Our answers are -5 and 1. So on a number line, if we plotted that, -5, 1, boom, boom, we're done. Piece of cake. We got it on lock. We're doing real good with this stuff. Unit 1 test, you're going to have to solve probably 3 to 4 absolute value equations and or inequalities. How you feeling so far about the equations? Pretty good? Awesome. So if I move this box out of the way, I think under this box is the solution. No, there's a plan there. It says, is there a simpler way to think of the problem? I don't know why they did that. That's weird. Whatever. All right. So they're talking about distance from 0 on a number line. They're saying it can't be negative. This is a good point they're making. They're saying if you have some kind of absolute value expression set equal to a negative number, there's no solution. So now they're talking about that gross thing that I said we're going to have to talk about. So the first thing to take out of here, what they're saying is if you have the absolute value of some stuff and it's set equal to some negative number, that particular equation is going to have no solution. Okay. The second thing they're saying is sometimes there's placenta. Sometimes there's placenta. Anybody know what placenta is? It's a membrane. It's a structure in which a fetus lives during the gestation period. Right? The umbilical cord is attached to it, and mom is eating pickles and peanut butter and cheeseburgers with maple syrup on them, and the baby's getting food through that, and the baby lives inside the placenta. Right? This isn't a bio class, okay? But what happens after the birthing process to the placenta? Anybody know? Where it goes? The what? Say it. It comes out. It's some people call it like the afterbirth, like the sac pops open, and so there's all this like skin there that's popped open, and that has to come out too. And in America, we just discard it. We throw it away. Well, lately, there's been research that says, and there's this thing about the umbilical cord and cutting the cord, and I don't know, they want to have people, cut the cord right away. Anyway, that's a whole nother debate. They say if you leave the cord hooked up a little bit longer, that there's more nutrients at the very end. Anyway, you don't want to know all that. Anyway, the point is in America, we throw the placenta away. It was a good thing when we solve these equations. There's extraneous solutions. What I mean by an extraneous solution in a placenta is this. We did really good math. Mom did a great job of giving birth to the child. And then we discard the answer that doesn't work. Okay? The placenta, we don't need it when we're done with it. And in America, we discard it. I'm not going to tell you what they do in other countries with it. I'm not going to tell you. Unless you want to know. I don't think I better tell you. Problem 3, here we go. We're going to have to set up 2 equations. Now, remember we set up one equation where 3x plus 2 equals 4x plus 5. So we set up one equation identical where we just dropped the bars. Here's where things get a little unusual. When we set up this second equation here, we still keep this the same, 3x plus 2. Now that's going to equal what? There's a couple different ways to go about this. What's that going to equal? If it was just a number, we'd say it equals the opposite of that number, right? Well, it's not just a number, it's a quantity. So we need to say that it's equal to the opposite of that quantity. So how do you represent the opposite of that quantity? With a negative sign. And notice how I put parentheses around the quantity. You'll hear me say this a lot in Algebra 2. Make sure that you quantify a quantity. Make sure that you quantify a quantity. Okay? Earlier I mentioned the distributive property. Here's where you need to use the distributive property. Okay? Which equation do we want to solve first? The one on the left or the one on the right? The one on the right? Okay. Go ahead and solve the equation on the right. So we're going to we'll subtract 3x. So we get x plus 5 equals 2. I said equals 2. And then we subtract the 5. So we get that x is equal to negative 3. That's one of our answers, we think. We think x equals negative 3. We did some really good work. We gave birth to a healthy baby. Anybody ever been around a baby that's been born? Or like when people are talking about babies, they said, "Oh, my Aunt Flo, she just gave birth. What'd she have? She had a little baby. Of course she had a little baby. Babies are little. She had a little boy. She had a little girl. Of course it's little. It's a baby." Anyway. All right, let's solve this other one. Solving this other one, remember we got to use this distributive property. 3x plus 2 is going to equal negative 4x minus 5. Who can read my mind and tell me which side of that equation I'm going to put all of my x's on? The left. Yeah, I like having positive x's. Okay, so I'm going to go ahead and add 4x to both sides. So I get 7x plus 2 equals negative 5. So I guess then we'll have to subtract the 2. So we'll get 7x is negative 7. And then we divide by 7. So x is negative 1. So we get 2 answers. We get x is negative 1 and x is negative 3. At some point this year, I'm going to show you a video. It's really cool. It's called Mathematicious. Anybody remember the song Fergalicious? There's this really nerdy math kid that does this video. It's great. It's called Mathematicious. If you get a chance, check it out. Anyway, one theme that comes up over and over again, he says, check your work. Because that's what math teachers tell you, right? Check your work. So we better go back and check to see if this value satisfies or makes true the original equation. So if we go back to the original equation, I'm going to have to do some work checking. Do you mind if I put the work checking here in the middle somewhere? Mind if I do that? So I'm going to check my work. 3 times negative 1 plus 2, all that's an absolute value. Is that really equal to 4 times negative 1 plus 5? So 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Is the absolute value of negative 1 really equal to negative 4 plus, is that equal to 1? Is that true? It is, right? So the deal is, this solution checks out, and that is one of our answers. That's the baby. That's a little baby. 8 pounds, 7 ounces. We'll name it Sheila. Okay. Well, let's check the other one. Is the absolute value of 3 times negative 3 plus 2, is that equal to 4 times negative 3 plus 5? 3 times negative 3 is, somebody help me out. Negative 9 and then plus 2, so that's going to be negative 7, right? Is negative 7's absolute value equal to negative 12 plus 5? Is negative 7's absolute value equal to negative 7? No, remember absolute values are distances. So this is not true. This is not true. So what do we say about this answer? It's the placenta. It served a purpose. It's a shell. It's some good math that we did, but we don't need it because it doesn't satisfy the original equation. So even though we did all this good work, we got an answer. This is the placenta. And what we say then is we say this is the extraneous solution. We say it's extraneous. What that means is it doesn't satisfy the original answer. So our only solution to this is that x equals negative 1. If you don't believe me, I'm going to use Desmos to verify this. Okay? There's a lot of latency with my graphing calculator, so I'm going to verify this with Desmos. Okay? So I'm going to go to the World Wide Web. I love what they say about Desmos. Desmos, so great, so great. If it loads, you can probably see it in the tab. It says it's a beautiful, free, beautiful and free. There it goes. Start graphing. Come on, computer, you could do it. I think my computer needs more RAM. Anybody know what RAM stands for, just for trivial pursuit's sake? Yeah. Random access memory. Good. Good one on you. So when I go to Desmos, what I'm going to do is I'm going to graph the absolute value of 3x plus 2, and I'm also going to graph 4x plus 5. And I'd like to see where those graphs meet if the web page decides to load. And it might not. Might have to use my TI Inspire. My mouse says, yeah, no, we don't want to use the TI Inspire. Insert graphs. Here we go. So is the absolute value of, where's my mouse? There it is. What was our absolute value expression? Thank you, 3x plus 2. And then our other expression was 4x plus 5. Thank you. I said 4x plus 5. There we go. Okay, so it's pretty clear that these things intersect when x is negative 1. Do you think they intersect when x is 3? Doesn't look like they do, does it? Okay. Are there any questions up to this point about solving absolute value equations? Couple things to take away. If the absolute value of some expression is set equal to a negative number, there's no answer, no solution. If you have variables over here and variables over here, you might have extraneous solutions. That's about the only time that's going to happen. If we have variables, if you end up with variables over here too, that's probably the only time you need to look out for that. For those of you that like to look for shortcuts, that's a safe bet. Not always going to be extraneous, but that's the shortcut. Okay. So the last thing we need to talk about then is rowing a boat, and lifting weights. Rowing a boat and lifting weights. Anybody ever see a rowboat? See if I have any people I could put in my rowboat. I'll put Kool-Aid Man in the rowboat. Oh yeah. Kool-Aid Man in the rowboat. Maybe I'll send him to the back. Here we go. Kool-Aid Man in the rowboat. All right. Now, how do we row a rowboat? What do we need? Oars. We need some oars to row a rowboat. So here's an oar here, and here's an oar here. All right. Okay. And when we lift weights, they kind of look like this, don't they? The barbell, that's about all the more I can lift. Anybody know where I'm going with this? Yeah. Has to be balanced on both sides, and when we get into solving these absolute value inequalities, there's basically two different types that occur. And when you graph your final answer, one of them is going to look like that barbell, and one of them is going to look like the oars. Now, maybe Kool-Aid Man is too hyped up on Kool-Aid, and so his oars are going straight out to the side like this. Okay? But what, we row the boat with the oars, right? I'm going to misspell the word oar. And we're lifting. See where I'm going with this yet? So anytime we have an absolute value expression, absolute value of stuff, and it's set greater than some number, this is the situation we're going to have. We're going to have Kool-Aid in a boat with the oars. Our graph is going to look like some oars. Actually, with the, do you see how Kool-Aid Man's oars, how the dot on the end of those oars are closed in? That would actually be greater than or equal to. If it was just a greater than, they would be open circles. And then the weightlifter's barbell, that's going to happen whenever we have the absolute value of some stuff set greater than, I'm sorry, I just used greater than, less than or equal to some number. There's a couple of B words that I like to associate with these ideas. One of them is enigmatic. It's the great beyond. Any flat earthers in here? Anybody believe in the flat earth theory? I tell you what, I did some research into it in the summer. Some of it makes sense. Some of it really makes sense, but whatever. I'm a conspiracy theorist. I'll go on record and say that. I don't want to talk too much about it today, but so the ones beyond and the others between. Okay. So when you write up your answers to these kinds of questions, your answers are going to have to be written in a specific way. Your answers need to be written in a specific way. If you have something that's beyond, you'll have x is less than or equal to some small number, small number. You'll have to write the word or, and then you'll have x is greater than or equal to some large number. Okay. One of the numbers is going to be smaller. When I say smaller, I mean on the number line, it's relative location. So x is less than or equal to the small number, or x is greater than or equal to the large number. With the other case, the between, you'll have x, you'll have a less than or equal sign there, a less than or equal sign there. And you'll have the small number on the left, the big number on the right. Okay. It's much the same way that we had to set up two equations, we're going to have to set up two inequalities. We ready to try a couple of these? Okay. We probably won't have time to talk about the tolerance problem today, so we'll have to pick that up another day. So here we go. Solving the absolute value inequality where the absolute value of something is less than some number. Right off the bat, who can give me the idea, who can tell me what the graph of our solution set's going to look like? Oars or a barbell? Oars or the barbell? The absolute value of some stuff is less than a number. Oars or a barbell? It's going to be the barbell, right? Okay. So our answer is going to be looking like this when we're done. We don't know what these numbers are, but here, I just want to give you a clue as to how my brain works when I'm grading one of your tests or quizzes. You could not know how to solve this inequality, and you could get a passing grade if you just did this much. You don't know what these numbers are, but you do know that you're going to use open circles or closed circles here. Open circles, because it's not equal to. Everybody understand that, I hope? And it's going to look like a barbell, so are we going to be shading between or beyond? We're going to be shading in between. And when we write up our answer, x is going to be between two numbers. If you did that much, I would give you 3 out of 5 on a test question. That tells me that you understand. Our answer is going to look like that, and you just didn't find the two numbers that the answer is. But if you wrote that much, I would give you a 3 out of 5 on a test item. Does that make sense? Does it make sense why? To me, that's a bigger idea than getting the number. Because here's the kind of stuff that most people pull. Most people do this. 2x minus 1 is less than 5. 2x is less than 6. X is less than 3. Okay? So then they'll put a negative 3 here and a 3 here. And that's wrong. X is less than 3, so this 3 is okay here. This 3 is okay here, and that 3 is okay there, right? So when you go to set up that second inequality, anybody remember what the trick is, what happens when you set up that second inequality? You have to change a couple things, right? It's not going to be 5, it's going to be negative 5, and what else? Not distribute, not parentheses. That inequality, that less than, so you're going to have to change that to a greater than. Remember doing that? Did they ever tell you why? I don't know if we have time to talk about why, but anyway, so you're going to have 2x is greater than negative 4, and x is greater than negative 2. So there it is. There's our answer. Graphed. There's our answer. The numbers are negative 2 and positive 3. What's kind of unusual is that there's two answers in one. I don't know if anybody can picture this. Do you see this expression right here? Can you read that from right to left? If you read that expression from right to left, what's it say? X is greater than negative 2. Does that make sense? We're so used to, in America, reading from left to right. Maybe we should take a page out of the Chinese book and learn to read the other way sometimes. And if you look at this expression, it says that x is less than 3. Right? Make sense? All right. We got one more item up for bids. Last one of the day. This is it. I'd like to take this time to give a shout out to my first period class. They've been awesome today. They brought their A game, most of them. They're attentive. They're with the program. Public service announcement before we get too far into this last one. And this is just a little side note. Spelling. I know this isn't English class, but I will hold you accountable to spelling, especially on an open note quiz where you're allowed to use your notes. Some people on the quiz misspelled a couple words. If we talk about these numbers, what are those numbers called? They're called the integers. Some people spelled it integers. They're not integers. Some people spelled it, and it does, I can understand where this comes from. Some people said it's the intigers. The intigers. Roar. Anyway, these are the integers. I know you whatever. Anyway, mind your spelling on some of those things. So here we go. Last one. Is this going to be the barbell or the boat? Boat. Going to be the boat. So we're going to set up our answer before we're even done. Number line. Whoa. Number line. What kind of dots? Closed-in dots or open dots? I'm hearing open, I'm hearing closed. This is or equal to 6. Or equal to 6. Because of the or equal, that's where we fill in the dots, because it could be equal to those, right? Because of the greater than, we know this is going to be like the rowboat. So here's my oars. Here's my oars. Here's my oars. When I write up my answer, I know that x is going to be greater than or equal to the large number, or x is going to be less than or equal to the small number. So again, if you just write this much on a test question, I will give you a passing grade, regardless of whether you find the critical values that satisfy this. That tells me that you understand these concepts. Two equations. The first one, 2x plus 4 is greater than or equal to 6. 2x is greater than or equal to 2. X is greater than or equal to 1. X is greater than or equal to 1. Is it plus or minus 1? No, I don't think so. So we got to set up that other inequality. What's that other inequality going to look like? 2x plus 4 is what? Less than or equal to negative 6. So 2x is less than or equal to negative 10, and x is less than or equal to negative 5. Good. That's it. What do we think? Make sense? Got them? Feel all right about it? Good. Well, it's been real. It's been fun. Hope everybody has the best day of their lives. Happy Thursday. Have a great day.